Here comes the first of our strategies for apportionment, and it's Hamilton's method. So Hamilton said, let's just first assign each district the number of seats according to their lower quota. If it ends up being the correct number of seats, so we've given out all of the ones we have to give out, great, we're done. If not, then we assign the extra seats one by one to the districts in descending order of size of the fractional parts. I'm going to show you what that means in a second here. So we're going to do that here. I'm just taking the table from that previous page, page 98. And we're to assign all of these lower quotas. So let's first see if that adds up correctly. 2 plus 6 is 8. Plus 3 is 11. Plus 5 is 16. Plus 1 is 17. So this adds up to 17. That means we have 3 more seats to give away. So what seats do they go to? Well, he says by size, descending size of their fractional parts. Well, the fractional part means this decimal here. So we're going to find the largest decimal, and it turns out there are 3 numbers that are tied for the largest decimal. District 1, 0.67, District 2, 0.67, District 5, 0.67. The next largest fractional part is this 0.58, then the 0.42, and that's all of them. So what happens is we add 1 to each of those districts with the largest fractional part. So each of these get plus 1 as their seats. So this becomes the apportionment. District 1 gets 3 seats, District 2 gets 7 seats, District 3 gets 3 seats, District 4 gets 5 seats, and District 5 gets 2 seats. Notice when we add these together, 3 plus 7 is 10, and then 5 plus 5 is 10, we get a total of 20 seats, and this is the appropriate apportionment following Hamilton's method. Okay, turns out there's other methods. So Jefferson, another one of those dudes, said, okay, let's do it a different way. And this guy said, well, we're going to use a modified divisor. We're not just going to we're not going to use these fractional parts. Instead, if the sum of the lower quota is less than the number of seats, we're going to get a new divisor that is less than the standard divisor and recalculate the lower quotas. In other words, we're going to keep calibrating our lower quotas until we get the number of seats that adds up to exactly what we're trying to give away. So here goes, we got the data again. We started with a 12 as our divisor with the lower quotas, and remember we got to 17. So since that's below the number of seats we wanted to give away, we're going to choose a modified divisor that is smaller than 12. So our author says use 11. That means we have to go through and divide each of these things by 11. So let me demonstrate that in Desmos. Notice I still have these numbers in here. So I'm going to go ahead and just change each one to 11, and that'll give us our standard quotas, except we're missing the District 3, which is 41 divided by 11. Okay, so let me write these down. The modified quota for the 32 is the 2.91, and then for the 80, 7.27, and the 67 is 6.09, and then the 20 is 1.82, and that 41 is 3.73. Now notice what's happened to our modified divisors. Notice what's happened to our new standard quota. They've all gotten larger. 2.67 went up to 2.91. 6.67 went up to 7.27. 3.42, 3.73. So when we divided by a smaller number, as we knew from back in chapter 1, earlier sections, it increases the size of the number. All right, so now we list out our new lower quotas. Well, this is 2, 7, 3, 6, 1. Notice that if we compare it to the lower quotas before, we've actually only increased 2 of them. So we didn't increase it enough. Let's double check that. Let's add these up. 7 plus 3 is 10. 6 plus 2 is 8. Plus 10 is 18. Plus 1 is a total of 19. Does it work? No. We still have 1 seat to give away. where Jefferson's method begins to feel tedious. So what are we going to do? Well, our next attempt will be to change the divisor again. And should we make it bigger or smaller? Well, I say we should make the divisor smaller to get more seats allotted to each district. Okay, so again, he's prescribing what divisor to use. Now it's 10.5. Let's get to Desmos, and let's get this with 10.5 for each of these. Remember what this is meaning here. We're saying 10,500 individuals per representative. Oops. Come out. All right, let's write these down. Okay, so I've got these written down. Let's compare our new modified quotas. Well, actually, why don't I write down the new lower quotas, and then we'll compare them to our previous one. So again, to get the lower quota, you just take the whole number. And what's happened? Well, notice we've increased a 2 to a 3. 7 stayed the same, 3 stayed the same, 6 stayed the same, and 1 stayed the same. So we're good. We've gotten it. We've added one more seat. Let's double check. 3 plus 7 is 10. 3 plus 6 is 9, plus 1 is 10. 10 plus 10 is 20 seats. So we have correctly allotted the seats by messing with the modified divisor. Turns out Jefferson's method was used in Congress until 1842, and then it was replaced with this new method divided by Daniel Webster. And he was apparently a 2-time Secretary of State. He also uses modified divisors, but it's based on standard rules of rounding rather than lower quotas. So again, we're going to assign each district the number of seats by using standard rounding rules on the standard quota, rounding up if it's 0.5 or greater, or rounding down if it's less than 0.5. If the sum ends up being equal to the number of seats available, we're done. If not, we modify the divisor, just like we did up here, and divide again and create new lower quotas.